Hello, this is the first video in the Calculus 3 series on integration using partial fractions for OCR Pure Core Further Mathematics, and it revises partial fractions. An algebraic fraction with multiple factors in the denominator can be split into the sum of individual fractions for each of the denominators. For example, we'll look at x minus 9 divided by x plus 1 times x minus 4, which we show can be expressed as the sum of two fractions with denominators of x plus 1 and x minus 4. So, we know that the denominators are going to be x plus 1 and x minus 4, but we're not sure about the coefficients or the numerators for each of those fractions. If we were to multiply up by x plus 1, x minus 4, we would get that x minus 9 equals a times x minus 4 plus b x plus 1. Now, we can use specific values of x on this identity in order to work out these values. So, if for example we chose that x was going to be equal to 4, then the x minus 9 would be minus 5. The x minus 4 would be 0, so we won't get a times anything. And we would have x plus 1 is 5 lots of b. This then tells us that b must equal minus 1. If we choose x equals minus 1, then x minus 9 will be minus 10, and we will have minus 5 lots of a and 0 lots of b. Therefore that tells us that a must be 2. So we can write that that fraction is going to be 2 over x plus 1 minus 1 over x minus 4. Where we have a repeated factor in the denominator, then we will split these into slightly different partial fractions. We will have a partial fraction with x minus 1 as a denominator, and also one with x plus 3. But in addition, we will need to use that repeated factor as well, with an x plus 3 squared. Multiplying by the x minus 1, x plus 3 all squared, we would get that x plus 15 equals a times x plus 3 squared plus b x minus 1 x plus 3 plus c lots of x minus 1. Let's choose our x values carefully to work out those coefficients. First, let's set x equal to 1. We would get that 16 equals 16a, so in other words 1 plus 3 all squared, so 4 squared is 6, tells us that a must be 1. Let's choose x equals minus 3. In that case, we would have 15 minus 3 is 12. The x plus 3 brackets will be 0, and therefore we just have minus 3 minus 1 minus 4 lots of c, telling us that c must be equal to minus 3. So how do we find the b coefficient? Well, if we look at the terms in x squared. X plus 15 has no x squared terms. And on the other side of the equation we would have an ax squared and also a bx squared. Well, we already know a is 1, therefore b must be minus 1. And we are able then to determine that x plus 15 over x minus 1 x plus 3 squared can be written in terms of partial fractions as 1 over x minus 1 minus 1 over x plus 3 minus 3 over x plus 3 all squared. So in summary, using a slightly different example, we notice that for linear factors we're going to have a constant numerator, and for repeated factor we form a fraction for each power. So the technique for partial fractions is as follows. We split the fraction into a sum of fractions, one for each factor in the original. With a repeated factor, we form a fraction for each possible power of a repetition. So for example, if there had been a cubic fraction, we would have had, say, x minus 1 squared, and then also x minus 1 cubed. We multiply through by the denominator and use selected values of x to zero out each factor in turn in order to identify those coefficients. If necessary, we look at the coefficients of each power of x to find any remaining constants. In the next video, we will consider partial fractions with denominator of the form ax plus b cx squared plus d.